Okay, here we are. Another question. Just give it a moment to make sure the live stream is working. Let's see if it was working. Yep, it's working. Very good. Pop the chat out and begin. So this question is coloring a border. This is 1034. And let me let's get it going. Coloring a border, you are given an M by N integer matrix grid and 3 integers row, column, and color. Each value in the grid represents the color of the grid square at that location. 2 squares are called adjacent if they are next to each other in any of the 4 directions. 2 squares belong to the same connected component if they have the same color and they are adjacent. The border of a connected component is all the squares in the connected component that are either adjacent to or at least a square not in the component or on the boundary of the grid in the first and last row or column. You should color the border of the connected component that contains the square, grid, row, column with color. Return the final grid. Okay, I have no idea what they're talking about here, but let's try to follow along. So its M by N is only 50 by 50, so it's not too large. It's about 2500. And grid IJ and color are between 1 and 1000. And, okay. Okay, so examples 1, 1, 1, 2, 0, 0, color 3. So we get 3, 3, 2. Okay. Adjacent, next to each other in any of the 4 directions. Same connected component, they have the same color and they are adjacent. Okay, so 1, 1, 1 is the same color, same connected component. The border of a connected component is all the squares in the connected component that are either adjacent to a square not in the component or on the boundary of the grid, the first or last row or column. Okay, so those are the borders. Color the border of the connected component that contains the square, grid, row, column with color. Oh, interesting. Okay. Oh, that's interesting. So, yeah, I mean, basically just a flood fill, and then you only color in the elements that are borders. That's not too hard. That's not too hard. All right, let's try it. So flood fill. And then yeah. Yeah, I'm going to use a DFS for this. And we'll say flood fill. I think I know what to do here. Oh, that's interesting. Okay. Well, yeah, we can do it this way. That's fine. Okay. I think that's all I really need to do is just have the target. Let's visit or none. We'll just say visited of I suppose it's something like the following. So visited of RC equals true, And then we're gonna say if it's not in bounds, so row. Yeah, okay. Row is greater than equal to 0. Row is less than n. C is greater than equal to 0. And C is less than n. If it's not in bounds, we return. Don't do anything. Or if it is in bounds, right? If it's not equal to the target, and we also skip it. Now we're going to say visit is true, and then we're going to say const bool, or no, bool border equals false. So for each direction, right, we're going to have int dr dc. It's going to be dr dc is, oh, yeah, actually, this is easier. Let's do it this way. Vector of bools. Okay, that's fine. Yeah. Okay, whatever. It's easier to think about it that way. It's fine. Okay. So border is false. We're gonna say each direction, and then current direction. Yeah, let's just say count. Increment the count and update the direction. It's gonna be a swap on drdc, and I think it's dc times equals -1, something like this. And just count is less than 4. So the number of rows. So yeah, incrementing the column by 1, we go to the right, and then we're gonna go clockwise, which means swap and then negate the second value. So we get 1, 0, 1, 1, 0, 0, -1, and then -1, 0, and then again back to 0, 1. Okay, so those are each of the directions, and then we're going to say if, so border, so we're going to say const bool boundary is new r is r plus dr, and new c is c plus dc. And we're going to say boundary is going to be the same routine as this, but with if it's not in bounds, or this is all in R and in C. Then we're going to say border or equals boundary, and then say if border, we're going to say grid of RC equals color. And we're going to say if not visited of an RNC, say if not boundary, I would say out of bounds. That's easier. If it's not out of bounds and it's not visited, then we can then RNC with F. Yeah. Okay, I think there might be like a slightly better way to optimize this, but this is like reasonable. This works more or less. I think this is all I need. Wait, what? Oh. Some minor errors here. I think this is all I need. I'm not sure. It could be more to this. Oh, look at that. Okay. Wait, what? Wait, what? Oh, it's only the border. Okay. Why does this end up being... What? Let me think about this for a minute. I think I know what the problem is. Something like this. Yeah, because if it's not equal to the target, it could have been something that was written with the color earlier, and we want to ignore those ones. Those basically are just borders that we already overwrote. Okay, so it's got to be something, one of the neighbors is not equal to the target. Yeah. Okay. It's pretty straightforward. Let me try to do a more complicated solution. So here 1, 2, 2, and 2, 3, 2. And what was the element? It was row 0, column 1, which is this 2. So this 2, 2, and 2 here. And this all gets written to 3. So you end up with this, yeah. Okay. Interesting. Interesting. Also, just if it's just in case, throw that in there too. Okay. I'm gonna go for it. There could be some mistakes there that I don't realize. Probably. I didn't test everything. Yeah. Okay. It's fine. I kind of expected there to be a mistake or somewhere. Maybe I should have tried this a little bit more, but I don't know. I just want to. I don't want to try to come up with a test case. Alright, so how is this one wrong exactly? What does it do wrong? There's some logical thing. It's minor, I'm sure. Not too big of a deal. Alright, this output has these 2's set to 2, and this should be 1's. Okay. So the color I'm looking to set is 1. Row is 1, 0, 1. Column 0, 1, 2, 3. These 2's, all these 2's. This 2, this 2. And then these 2's. Okay, those are not all of them get set to 1, only the ones that are bordering. So these all get 1's. These will all become 1's. These don't all become 1's. It's only this one becomes a 1. This one becomes a 1. What about these 2? This one does not become a 1. Right? It's not on the border. And this one becomes a 1. Because it's got a 1 here. So this is the only one that doesn't become a 1. Wait, what? Yeah, this one. These 2 become 1's. How come these didn't become 1's? Why? Oh, I see. Okay, I see the problem. Alright. That's really confusing. I mean... Alright. Let's forget this part. Forget this. Never mind, this is... Just keep it simple. there's probably a more efficient way to do this, but this is fine. Kind of bad on my part. I think there's a way I could have done this better, but it's fine. I think it's fine. Alright, I'm gonna go for it. Could still be wrong somewhere. Okay, there we go. That's better. That's pretty slow. At least it's correct. At least it's correct. It's in 16 minutes. Not great, but not terrible. Let me submit it a few times. It takes kind of a lot of memory. And it's kind of slow. Let's see. I kind of want to use like a breadth first search or something. Depth first search is fine too. Breadth first search is maybe a little bit better. Because depth first search you have like a stack you have to mess around with. Could also just say you can also do it this way. This is maybe another way of doing it. Using a sentinel value. Maybe uses a little bit less memory. You can try this way too. Excuse me. Whoa, it's wrong. Okay. Whoa. Wasn't expecting that. Really? Okay. I see. Wow. Oh. Uh-oh. No. Yeah, you need a way to mark them, but without necessarily disturbing them. That's pretty awkward, huh? That's confusing. Well. Try that now. Maybe that works. Okay, that's better. Yeah, that's confusing. That's really confusing. I think that's correct now. Okay. Is that faster? It uses less memory. 1, 2, 1, 2, 3, 4. Yeah, I didn't really think that all the way through, quite frankly. Kind of just went quick. Just went quickly because, just want to go quick. 1, 2, 3, 4, 5. We'll do 2 more. Alright, I think I'll stop there for that question. That's probably enough. Yeah, it's kind of random how fast it is. It's like, it's reasonable. It's okay. It feels like it should be a lot faster because it's only 2,500 elements, but whatever. It's fine. Okay, so yeah. Thank you for watching. That's that one. This is reasonable. It's not great, but it's reasonable. I definitely could have thought about it a little bit more. I knew there was something kind of unusual with like the colors and the boundaries which is pretty awkward, but it's fine. You just use some kind of sentinel value to keep track of that, I suppose. This also probably uses more memory than it really needs also with this, but I guess it's not the worst thing in the world. So that's not terrible, because you're already using, quite a bit of memory anyway. And this could, in theory, end up being the same amount of memory anyhow, because it could just be the whole thing you have to iterate through, so it's reasonable, this approach. Yeah, just go through it at the end again, and write what you want. That's fine. That's fine. Not amazing, but like it's okay. It's okay. There are probably slightly faster ways to do it, but this is okay overall. Alright, thank you for watching. I'm gonna stop it there and start again on a new question. If you like the stream, don't forget to follow and like the video. Alright, let me just check the chat before I go in case anyone wanted to say anything. Yeah, chat's here. Okay, alright, take care.